All right, so this is Unit 2A, Day 2, factoring GCF and trinomials. To answer our question, how do I factor whole numbers, I just want to stop right there and explain factoring as easily as I possibly can. When you're factoring a number, you're trying to come up with all of the numbers that multiply to give you that number. So if you're factoring the number 8, for example, what numbers multiply to give you 8? 4 times 2 is 8. And then I can break that 4 down to 2 times 2. So 2 times 2 times 2 is 8. That's the kind of thought process we should be having when we're factoring. Now, say you're given a big number, like 294. What is the prime factorization of 294? Okay, prime factorization means we're not just breaking down 294 into numbers that multiply to give us 294, but we're breaking it down into the prime numbers that multiply to give us 294. So I'll show you by example, and I'm going to show you a really valuable tool that you can use on your calculator. So let's stick with the number 294, and let's get those calculators out. So you're going to go to y equals, and we want to find out what numbers multiply to give us 294. So I'm going to type in 294, and then I'm going to divide by x. Okay, that x button, if you need help finding that, I can help you with that. Then you're going to go to your table. So you hit second and then graph. And what this does is gives you everything that multiplies to give you the number that you need. So we're looking for multiples of 294 or factors of 294. Don't choose 1 because that goes into everything. So let's use 2 and 147. So our 294 we can break down to 2 and 147. Okay. 2 is a prime number. You can't break that down any further because only 2 and 1 multiply to give us 2. That 147 we can break down further. So we're going to think of numbers that multiply to give us 147. And why don't we learn our use our newly learned tool using y equals. So you're going to go to y equals and clear out that 294. And now we're going to put 147 over x. Go to the table, and let's choose 3 and 49. Okay, decimals aren't very good, just like we don't want to use 1 and 147. That won't get us anywhere. Decimals aren't numbers we want to use either. So we want to use 2 integers, not including 1. So let's use 3 and 49. Okay, well this 3 is prime also, so I'm going to circle that. And then 49 is not prime. If you're not sure, just use y equals to find out what the factors of 49 are. So clear that out and put 49 over x. Go to the table. And you'll have to do a little scrolling here. As you can see, you have 1 and 49 and then all decimals. But there you go. You have 7 and 7. So 7 times 7 is 49. And 7 and 7 are both prime. So the number 294 factors could be 7 times 7 times 3 times 2. Hopefully that makes sense. If not, raise your hand and we can practice with some other numbers. So to answer our next question, when a number is completely factored, what kind of numbers do I have left? We're left with prime numbers. So how can I figure out if the following polynomials? So now, instead of just whole numbers, we're going to talk about factoring polynomials. And a lot of the same concepts apply. We want to see if something is factored correctly. To check, you can just multiply your answer back together. So if we wanted to see if 294 was factored correctly, you can do 7 times 7 times 3 times 2, and you're going to get 294. Go ahead and check it out. If you have 35x cubed y to the fourth minus 60x to the fourth y, I know that's a mouthful, but it would factor to 5x cubed y times 7y cubed minus 12x. And we're going to learn how to do that, but this is kind of a reverse thought process here. To check to make sure that it's factored properly, what you're going to do is multiply and see what you end up with. So 5 times 7 is 35. Okay, x cubed. There's no x in 7y cubed, so that's going to remain x cubed. And then y times y cubed is going to be y to the fourth. So when we multiplied this times this, we ended up with this. Just to make a point, I circled everything. You don't have to do that, obviously. Okay? Now, we're going to take this, multiply it to this. Okay, so we've already multiplied by that. Now we're going to multiply 5x cubed y times negative 12x. Let's see what we get. So with the minus sign, 5 times 12 is 60. Then the x cubed times x is going to be x to the fourth. And then we're just going to tag that y on there. This y. Okay? So, might seem like a big jump, but hopefully you see how they're related. So 35x cubed y to the fourth minus 60x to the fourth y. When factored, you get 5x cubed y times 7y cubed minus 12x. So bear with me. Through some of these examples, it'll make more sense. Now I'm going to show you also some tips you can use. So factoring technique number one that we're going to use, greatest common factor, often referred to as GCF. Okay, GCF stands for greatest common factor. I'm going to factor 8x to the fourth y cubed minus 2x squared y plus 4x cubed y squared by first finding the greatest common factor, which is going to go right here. And then I'm going to leave everything that I couldn't factor out in parentheses. So here's how you find the greatest common factor. You can use y equals to break down each of these numbers, 8, 2, and 4. In a matter of time, I'm going to break down the 8. That becomes 2 times 2 times 2. Okay? X to the fourth, we're on this term right now. X to the fourth can be expanded as x, 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 x. And y cubed can be expanded as y, y, y. So 8x to the fourth y cubed has now been expanded. I'm going to do the same thing with negative 2x squared y. Okay, that's a little easier. It's going to be minus, and then you have 2x, x, y. All right. Now we're going to move on to 4x cubed y squared. Okay, 4 breaks down to 2 times 2. And then the x cubed is x, x, x. And then the y squared is y, y. Okay? So now we're going to figure out what the greatest common factor is. And we're going to put it right here. Okay? So here's what you do. Look for everything that they have in common. Okay? So there's a 2 here, 2 here, and a 2 here. Okay? Now, I can't take out any more 2's because there's only 1 2 in this middle term, right? So the number 2 is going to be part of the greatest common factor. All right? Let's move on to the x's. I have an x here, an x here, an x here, and I can still keep going with the x's. Here's another x, and an x, and I stop right there. Again, because of that middle term, there are no more x's. So 2 x's would make x squared. Lastly, with the y's, you have a y here, and a y here. And again, because of that middle term, just so happens to be our greatest common factor here, you're going to only be able to take one y out. So our greatest common factor is 2x squared y. So let's put the rest back inside. So everything that wasn't underlined, we're going to multiply back together. Meaning this 2 times 2 is 4. We had x squared left over and y squared left over from that term. Okay? For this one, we used everything up, didn't we? So you don't have to cancel that up because you're going to be, or cross those out because you're going to be using your notes, but we use everything, but we don't want to put a 0 there because that wouldn't make our answer wouldn't make sense. So you put a placeholder and you use the number 1. All right? And then for our last term, what do we have left? We have this 2, x, and y. So what's left over there is plus 2xy. All right. So that's the easiest way I can think of factoring problems such as this. And if you guys come up with a better way, let me know. I'm always open to new ideas, okay? 9a cubed b plus 3ab squared. I'm going to pause it and work that one out. You guys can try it on your own, but I'm just going to work that one out and put the answer up here. So far I've broken down each term into prime factorization. Let's see what the greatest common factor is now. All right, there's a 3 here and a 3 here. So 3 is going to be part of the GCF. You don't have to have that line out there. I was just doing that for demonstration. You have an A here and an A here. So A is going to be part of the GCF. And then you have a B here and a B here. So B is going to be part of the GCF. So our GCF is 3AB. Okay, everything else that we didn't cancel out is going to go back inside the parentheses. So that will be 3 and then a squared, right? So 3a squared plus, all that's left here is that b plus b. So it's factored. And again, to make sure that you're doing this right, you can multiply your answers. So you distribute this 3ab to 3a squared plus b, and you'll be put right back where you started. You did that as your answer. Okay, I don't want to do that for you here, but you guys will get some opportunities to do it in class. Here's an easier factoring type problem. Factoring technique number 2, general trinomials. So trinomials means there's 3 terms, and the a value, this applies when the a value equals 1. So the standard form of a quadratic expression I've written right here, that's ax squared plus bx plus c. So a is the coefficient of x squared, b is the coefficient of just x, and c is a constant. This works when a is 1. If you notice in all these examples here, a is 1. There's no number before the x squared. Okay? Real quick, I'm going to show you how to factor these. They all follow this pattern. You're going to have a parentheses with an x times a parentheses with an x. I'm going to show you how to find the other numbers. However, you'll have to, I just decided I'm going to make another video, so you'll have to watch part 2 of this video and check it out now.